Welcome to the Polynomial Division Notes. We're going to be talking about how to divide polynomials today. Before we do that, I'm just going to remind you of a few words. If you wanted to do the problem like 12 divided by 3 equals 4. 12 would be the dividend, because it would be the thing that would go like inside the fraction house. 3 is the divisor, and 4 is the quotient, the answer. This is the same thing as saying that whatever you were dividing by, 3, times your answer equals 12. Because when you divide something, you're just trying to figure out how many times it goes into it. So for example, my first problem, I'm really looking for what I would multiply x minus 7 by to get x cubed minus 13x squared plus 40x plus 18. And the first method I'm going to talk to you guys about is going to be the reverse box method. I'm basically going to figure out what I have to multiply by to get what I want. So let's jump right into it. We're going to draw our box to start with. Awesome. Then we're going to put the denominator over here along the side. And we're going to draw our first column, and we're going to have a row right here. And you're going to put the first term of the dividend, which is essentially the numerator, in the top left of the box. And then you're going to try and figure out what goes along the top so that x times whatever I'm going to put here equals x cubed. Well, hopefully you know that x times x squared is x cubed. So I'm going to put x squared right here. Then I go ahead and I multiply that x squared times the negative 7. The next thing you need to remember or know about multiplying together is that whatever I put here is going to make this next spot also an x squared, so that these two things get added together to equal negative 13x squared. So the question you need to ask yourself is, what number do I need to add to negative 7 to get negative 13x squared? Negative 6x squared. Because negative 7x squared plus negative 6x squared equals negative 13x squared. Then if that's negative 6x squared, then you're looking for x times what equals negative 6x squared. Hopefully you know that that means it needs to have a negative 6. Let me go ahead and erase this because we don't really need it there. And to get x squared instead of x, you need another x. Then you're going to take that and multiply it. Negative 6x times negative 7 is going to be positive 42x. Then you're going to use the next diagonal to figure out how you get 40x. Well, if you already have 42 and you need to get to 40, you're going to have to subtract 2x. And x times negative 2 is negative 2x, which gives us the last thing that we would need to multiply by. Then negative 2 times negative 7 is positive 14. Now you'll probably notice, if you look, that 14 is not the same thing as 18. So we need to add 4 off to the side to make it equal 18. That right there is our remainder. And when you have a remainder in a division problem, you need to write it as a fraction over whatever you were dividing by. So my final answer to this problem is going to be x squared minus 6x minus 2, because that is the thing I would multiply x minus 7 by to get what I was trying to get to. Then if you have a remainder, you have to add it as a fraction over whatever thing you were dividing by. Let's try one more because it honestly makes more sense the second time around. I'm going to go ahead and draw my box. And I'm going to put x squared plus 0x plus 1 because you need to put a 0 placeholder, meaning if a problem skips a power, you leave a 0 in its place. Because there was no x in the middle right here, I have to write 0x right here. Otherwise, my powers won't line up correctly. Then I'm going to do the same thing I did on the last one, where I put the first thing inside. And then I ask myself, x squared times what is x to the 4th? X squared. Then I multiply x squared times 0x, and I get 0x to the 3rd, and x squared times 1 is x squared. I need to then focus on my next column and making sure that this diagonal of x cubes adds up to 4. Which, if I don't have any at all, I need to put all 4x cubes in this one because I have 0. So I need to add 4 to get 4x cubed. Then I ask myself, what do I multiply x squared by to get 4x to the 3rd? 4x. And I take that 4x and I multiply it the rest of the way down. And then I worry about my next diagonal of x squareds, making sure that they add up to 3x squared. I have 1 and then none, so I just have 1 plus 2 will get me 3. And if that's 2x squared, x squared times what gets me 2x squared? 2. 2 times 0x is then 0x, and 2 times 1 is 2. So this time, that number matches, and I also have 4x like I'm supposed to. So all of the numbers work out perfectly. I do not have a remainder, so my answer is the top of the box, x squared plus 4x plus 2. So essentially this method is just figuring out what you have to multiply by to get what you want on top. Now let's talk about long division for a minute. For long division, you're going to basically go back to elementary school for a second. If I wanted to divide 1,848 by 12, I would put a 12 out front and 1,848 inside. Then 12 can't go into 1, so I'm going to do 18. 12 goes into 18 once. That would have been an answer of 12, so I subtract 12 from 18 and I get a remainder of 6 before I bring down the 4 that was next to the 18. Then 12 goes into 64 5 times, but that's only 60, so I subtract 60 and I get a remainder of 4 before I bring down my last number, which is an 8. 12 goes into 48 4 times, which works perfectly, so I don't have a remainder. And 1,848 divided by 12 is 154. we're going to do the same thing, but with x's and exponents instead of just numbers. So what you're going to do is write the problem with that division symbol like I just showed you, like this. Then you're going to divide the first two terms. So essentially I'm going to be doing x cubed divided by x, which is x squared. So I'm going to write that right here. Then I multiply that answer by the divisor, which is the thing outside. So x squared times x and x squared times -7. X squared times x is x cubed. X squared times -7 is -7x squared. And I'm going to erase those lines because they end up looking really confusing later. Then your next step is to subtract the dividend minus that product that we just wrote. So basically you're going to subtract these two things. Just be careful because when I do -13 minus -7, that's actually -6x squared. Because subtracting a negative turns into a plus. Then I drop this down just like I dropped down the 4 right here. And we repeat. Divide the first two. 6x squared divided by x. And I'm going to write that over here to the side in case it helps you. That's going to be 6x. So that's what I'm going to write up here. Then you take that 6x and you multiply it times both of those. So 6x times x is 6x squared. Sorry, I missed a negative really quick. Let's go fix that. Right there. -6x squared divided by x is -6x. And then -6 times -7 is 42x. Just don't forget that you are subtracting these. So -6 minus -6 is 0, and 40 minus 42 is -42, or -2x. Then you would divide -2x by x, which is just -2. You take that -2 and you multiply it by the two numbers in the front. So after you get an answer on the top, you multiply it by the two in front. That's going to be -2x and +14. Then I've made a really common mistake. I'm going to fix it in just a second. If I subtract these, -2 minus -2 is 0. I don't have anything to subtract the 14 from because I had accidentally forgot to drop my 18. So now 18 minus 14 is 4. That is my remainder. So my final answer is x squared minus 6x minus 2. Everything from the top right here. And then my remainder of 4 over x minus 7. This is the same problem I did using the box method. So I've got the same answer, just two different ways. You do not have to be able to do both, but you do have to be able to use one consistently. Okay, let's do one last long division problem. Just like I did up above, since this doesn't have an x in the middle, I've got to put a 0x there. And then I'm going to divide the first two. X to the fourth divided by x squared is x squared. Then you take that x squared and you multiply it by all three of those. Okay, I'm not going to leave those lines there because it ends up looking really confusing. But that's going to give me x to the fourth, 0x cubed, and 1x squared. And then I just have to make sure I subtract those. X to the fourth minus x to the fourth is 0. 4x cubed minus 0x cubed is still 4x cubed. And 3x squared minus 1x squared is 2x squared. Then you drop the next one down. And you divide the first two. 4x cubed divided by x squared is 4x. Then you take that 4x and you multiply it by everything in front, and you get 4x cubed, 0x squared, and 4x. Then you subtract these. 4x cubed minus 4x cubed is 0. 2x squared minus 0x squared is 2x squared. And 4x minus 4x is 0. Just don't forget to bring down this 2. Then I divide the first two. 2x squared divided by x squared is just 2. 2 times x squared is 2x squared. 2 times 0x is 0x. And 2 times 1 is 2. When I go to subtract these, everything matches, so I get a remainder of 0, which means my answer is just whatever was on top, x squared plus 4x plus 2. The last part down here at the bottom is just explaining that you can use division problems to factor. For example, if I'm going to I'll use the box method on this one, and I'll use long division again on the last one. So on this first one, I'm going to draw my box, and I'm going to put 2x minus 3 on the outside. Okay, and then I start my inside by putting the 6x squared inside. And then I ask myself, 2x times what is going to be 6x squared? Well, 2 times 3 is 6, and x times x is x squared. Then you go ahead and multiply that by the negative 3, so that would be negative 9x. And you want this next diagonal to add up to negative 11x. I already have negative 9x, so I need this to be negative 2x. And then 2x times what is going to be negative 2x? Well, that's just negative 1. And that makes my last number negative 1 times negative 3, which is 3. So it works, because that number is the same as that number. So my factors of this are 2x minus 3 and 3x minus 1. So instead of just saying the answer to the division problem is 3x minus 1, we're actually taking it one step further and saying that that multiplies by the 2x minus 3 I was dividing by to equal the thing on top. This only works if the remainder is 0. For example, 2 is a factor of 10 because 10 can be divided by 2 nicely. Okay, let's try the next one, but we'll use long division this time. Let's see, 7x minus 1 is going to go outside. And 7x cubed minus 8x squared minus 13x plus 2 goes on the inside. Then I'm going to divide 7x cubed by 7x. The 7's will cancel, and it'll just be 1x squared. Multiply that by 7x, I get 7x to the third. X squared times -1 is -1x squared. And then I just have to make sure that I subtract that, which I'm going to get 0. And -8 minus -1 becomes -8 plus 1, which is -7x squared. Drop the -13x. And now I'm dividing -7x squared by 7x. -7 divided by 7 is -1. And x squared divided by x is x. Multiply that back by the original, and you get -7x squared and positive 1x. And you just have to subtract. -7x squared minus -7x squared is 0. -13 minus 1 is -14x. Drop the 2 down. -14x divided by 7x is -2, which would give me -14x and 2. And if I subtract those, I get a remainder of 0. So my factors are 7x minus 1 and x squared minus 1x minus 2. Sorry, that one got a little funky. Yeah, I don't know why it's doing that this time. I'll just circle it myself.